Hello and hi everyone. This is a video presentation from Group 2 under the topic of backtracking. My name is Nurul Animihandani Binti Muhammad with metric number 1912728. Have you ever experienced losing or forgetting your items, but when you go to get the item is not there as you remembered? So you will start to rewind the last visited places or where it was placed before it went missing for you to go there to find the item. But if the item is not at the place you remembered, then you can go and find it in another place until you find the item. But do you realize that the action of tracking the previous places until you find the item is actually applying the backtracking algorithm? We can also see it in the game of maze. Maze is a game with a collection of paths starting from an entrance until you reach the goal. The rules for the game: you can take any path and it doesn't matter as long as you can reach the goal. Once you are blocked in the middle of the path, you can just turn back and find the other path to go through. Going back and finding the other path to reach the goal, that is when backtracking is applied. So, can you see the importance of backtracking in real life? Backtracking can help you to solve a variety of problems. When there are many possible solutions for one problem, we don't have to stick with one exact solution for us to solve the problem. If we can't solve it using A, we can still try using B, C, or D, or until we solve the problem. This is because through a backtracking algorithm, when a pattern doesn't work, we look for another one until we either run out of sources or we find out one that works. Backtracking can also help to find a practical solution to a decision problem and all practical solutions to the enumeration problem. Lastly, the backtracking algorithm also works as the most convenient tool to solve constraint satisfaction problems like map coloring problems, Sudoku, crossword, and all other logical puzzle games. To know more how the backtracking algorithm works, I'll pass to the next presenter. So that's all from me. Thank you.
So, how does backtracking actually works? Hi, my name is Muhammad Nifa bin Shamsuddin with the metric number 1913271, and I'll be explaining on how does backtracking actually works. Backtracking algorithm is a better brute force algorithm to solve problems. Backtracking will recursively call the function to find the solution by building step-by-step incrementing value. Those incremented value will be bring into the function and go forward further into the path, and during the whole process we will remove any solutions that didn't reach the end goal. There are three types of problem in backtracking. The first one is decision problem, where we try to find any feasible solution. In optimization problem, we try to find for the best solution, while in the enumeration problem, we try to find all feasible solutions that we have in our problem. So it does sound a little bit confusing, but in short, we can simplify into three simple steps. The first one, we're going to check if the current point we are right now is the goal. If it is, then nice, it's a success, we can stop here right now. But if it's not the goal, then we go for the second step. If it's is it the end point? If it's the end point, then we consider it as a fail. We can go back to the previous point along the path that we just gone through, and we try to look for another path that we haven't explored yet, which will lead to the third point. Is it not the end point and also not the goal point? Then we're going to repeat the whole process. As been said before, that backtracking is a recursively calling function, so we're going to repeat until we find what the goal is. That's all from me. We'll proceed to the next presenter.
Assalamu Alikum warahmatullahi wabarakatuh. I'm Nur Ashamiti Ahmad Irfan, and I'm going to continue presenting the project with the example, which is n queens problem. What is n queens problem? N queens problem is to place n queens in such a manner on an n times n chessboard that no queens attack each other by being in the same row, column, or diagonal. Here we have the solution of the example, but then we will further discuss in the next slides. So let's see here, this is an empty chessboard, which is 4 times 4, meaning we'll be having 4 queens, which is q1, q2, and q3 and q4. So the rule says that the queens cannot be next to each other in the same row, the same column, or diagonal. So let's say we are inserting Q1 as the first step. So we have many options in inserting the Q1, but we will take the first one, which is cell 1, 1, row 1, column 1, is where we are going to insert the Q1. And then we are going to insert Q2. See here we have two options in inserting Q2. First option is that we can insert Q2 at row 2, column 3, because it is not diagonal with Q1 or next to Q1 or under the Q1. And then the second option is that we can insert Q2 at row 2, column 4, which is very further away from Q1. How about Q3? See here we have option to insert Q3 at row 3, column 2, because it is not next to Q1 or not next to Q2 or diagonal to Q2 or Q1. See here we cannot insert Q4 because if we are going to insert Q4 at the last row, we say here the first one, which is row 4, column 1. We cannot insert it here because it is in the same column as Q1 and it is diagonal with Q3. Row 4, column 2 also cannot because it is under Q3. Same goes with row 4, column 3. It is diagonal with Q3. And then row 4, column 4, it is cannot also because it is the same column as Q2. So here we know that we cannot insert Q4, then we have to do the backtracking. So what is backtracking actually? We are going to go to the very first step, which is inserting the Q1. So we are going to take another option in inserting the Q1, which is at row 1, column 2. And then we are inserting the Q2 here at row 2, column 4, because we can see here this is the suitable place to insert the Q2. Next, inserting the Q3 at row 3, column 1. And then lastly, we can insert Q4, which is at row 4, column 3. See here that the placement of the queens are according to the rules, which is not in the same row, not in the same column, or not next to each other diagonally. So this is the solution to the backtracking. But the question is, what is the limitation of this problem actually? So here are two limitations of the n queens problem. It is very time inefficient in a lot of cases where branching factor is large. So as we can see before, when we are going back to the very first step, we are actually creating another branch, and therefore it is very time inefficient because we actually are taking a lot of time in solving the n queens problem, and we also have to perform redundant work. This means that when we are going back to the very first step, we have to repeat each step. But then let's say in the n queens problem we are finding another dead end, so we have to go back to inserting the Q1, and then we have to repeat it over and over and over again, and that is the means by redundant work. So that is all from me. Thank you.
My name is Nurul Binti Azizi with metric number 1914456. We'll continue the presentation by answering the question of when we should use the backtracking algorithm and when we should not use it. First, we will look at when we should use this algorithm. We use this algorithm when we want to find the best solution or decision, especially when there are multiple solution options. For example, we use it to solve puzzle-related problems such as Sudoku, n-queen problem, and others. Then, as mentioned previously by Brother Ifwat about the enumeration problem, it also uses a backtracking algorithm to find the set of all feasible solutions for the problem. Lastly, we will surely use this algorithm when the problem requires using the recursive function, because we need to explore all the nodes or options until it reaches the final solution. Move to the next part on when we should not use this algorithm. First, this algorithm is not suitable to be used when the problem requires limited time to find the solution. This is because as the possible solution increases, the time to explore and backtrack the path to find the solution also increases. Next, backtracking is not suitable for those who prioritize optimization while handling a large number of data or possible solutions. It is because backtracking uses recursive algorithm that consumes a lot of memory and processor, and as mentioned previously, it is time consuming. That is all from our group. Thank you and Assalamu Alikum.